Okay, next up, here's a toughie. This is an isosceles triangle. So here's an x, here's a theta, with theta there. 180 degrees is equivalent to pi radians, so this would be pi take away 2 theta. Cool. And what it wants is the arc length. The arc length will be found by L equals theta r, which will mean that we need theta, which is this, multiplied by this radius here. Okay, so in order to find out that radius there, I'm going to call it r. I'm going to use a cosine rule. The reason I'm going to use cosine rule is because I've got cos. I don't want to use the sine rule. Okay, I've got two options, but I want to use the cosine rule. So we've got r squared equals 2x squared, because that's x squared plus x squared, minus 2 times x, which is 2x squared, cos of pi subtract 2 theta. Cool. I'm going to factor the 2x squareds. Here, factor them a little bit early. Okay, that looks absolutely fine. Next, I don't want to have any brackets within my angle for my cos, so let's take a look at what pi subtract 2 theta would look like. There's pi, there's 2 theta, C, A, S, and T. Cos of 2 theta, cos of pi subtract 2 theta is negative because it's in the sine quadrant. Cos of 2 theta would be positive. Okay, the equivalent would be a positive cos of 2 theta. So we'll get 2x squared lots of 1 plus cos of 2 theta. All right, close those brackets. That's r squared there. Okay. All right, let's mess around with the cos of 2 theta now because I want it to be cos of theta. So let's see if we can get rid of this 1. So I get 1 plus 2 cos squared theta minus 1. 2 cos squared theta minus 1 is the equivalent of cos 2 theta, but it's the version that I like. You get a few different versions with cos 2 thetas. I just wanted to get the one where I can get rid of the 1s. So cancel, expand, and you'll end up with 4x squared cos squared theta, and r squared equals those things. All right. Root 2x cos theta. Done. Okay, now once we know that gives us our r, we need to multiply that by theta to get the arc length. So we'll multiply it by theta, we'll end up with r theta equals L, which equals this thing multiplied by theta, 2x theta cos theta. Done. Okay, that's tough. Next, find the shaded region. That will be the sector, subtract the triangle. Okay, well this would be 1/2 r squared theta, 1/2 times by r squared, which would be 4x squared cos squared theta times by theta, half r squared theta. Remember this is r, so I just squared every part, half r squared theta. Subtract half ab sine c, we're using this one, half of x times x squared, sine of pi subtract 2 theta. Actually, I don't need to go any further than this. I just got the area in terms of x and pi. It's done. There's no particular form it wants. I'm just going to tidy it up a little bit. 2 theta x squared cos squared theta subtract 1/2 x squared sine of pi subtract 2 theta. It doesn't need to go any further than that. Okay, it's fine. You don't need to do anything extra. You can factor out some bits and bobs, but you don't need to. No need to. All right, next. By first expanding this, so we're going to find the three solutions. Let's expand this. Cos theta times by cos theta is cos squared theta plus cos theta sine theta plus sine theta cos theta, so that'll be plus 2 sine theta cos theta plus sine squared theta equals 1. These add up to 1 as well, so that'll mean that 2 sine theta cos theta must have been 0, meaning that the solution set 1 will be if sine theta equals 0, and solution set 2 will be if cos theta equals 0. All right, inverse those, okay, and then cast it as you need to. Once you inverse those and you cast them as necessary, you're going to find out that sine theta gives you theta equals 0, and when you cast it, you find out pi, or you wave it, whatever you need to, and here theta equals pi over 2. Okay, those are the three solutions. They're found by just using inverses. All right, next up. Hence verify that the only solutions of the equation are just two of them, not the pi. All right, fine. Well, look at the difference between these. Okay, whatever this was, if it was equal to positive or negative 1, if you square it, you get 1. Okay. The weird part here is that obviously this isn't the squared bit. We're saying that this could have been positive or it could have been negative. Any of these could have happened. If it was positive or negative, we just don't know which one it would have been. So first off, I'm going to test it out. I'm going to go with cos of 0 plus sine of 0 and find out what that is. Well, cos of 0 is 1 plus sine of 0, which is 0, and you get 1. Okay, so actually that holds true for this equation and also holds true for this equation. Okay, fine. All right, cos of pi over 2 plus sine of pi over 2, that also comes out as 1. All right, next up, cos of pi plus sine of pi. Well, cos of pi will be negative 1 plus sine of pi, which is 0. You end up with negative 1, so it doesn't hold true for this part here, but it does hold true up here. All right, but what I'm asking about is this. Okay, so it doesn't work, so it's those two that work. There you go, verified it. All right, next up, proving this identity. Cross multiply, tidy it up, you're going to end up with sine theta cos theta minus sine squared theta plus cos theta plus sine theta minus cos squared theta minus cos theta sine theta all over cos squared theta minus sine squared theta. Okay, whole lot of work in there. This and this, they'll cancel out. These two, that one and that one, will turn into a minus 1. Okay, the reason they'll turn into minus 1 is because sine squared plus cos squared equals 1. So you're going to end up with 1 plus cos theta plus sine theta over. Here, this is 1 minus sine squared theta. Take away another sine squared theta. Remember, this is 1 minus sine squared theta comes from the sine squared theta plus cos squared theta equals 1. So that'll be 1 minus 2 sine squared theta. Okay, bit of a brutal one, but there it is. That should be a minus 1, by the way. Sorry, there should be a minus 1 because we've got minus sine squared minus cos squared. Make a minus 1. Apologies, that should be there, matching that. All right, minus 1 plus cos theta plus sine theta all over. Da, da, da. All right, next, using the results, solve this equation. So first off, we're going to express this tough thing as this. Okay, so that's going to be cos theta plus sine theta minus 1. So this will be cos theta plus sine theta minus 1 over, it was 1 minus 2 sine squared theta. Okay, and that is being made to be equal to 2 lots of cos theta plus sine theta minus 1. Okay, now to work with this should be quite a lot simpler than it looks. One of the first things we get is that the solutions are equal to each other when these two things are equal to 0. So one option is you get a solution set when cos of theta plus sine of theta subtract 1 equals 0, because these two sides would be equal if these were 0. That matches this bracket. Okay, the other solution would happen if 1 over 1 minus 2 sine squared theta equals 2. Okay, that's the other stuff. Remember, this could be a 1 multiplied by. Okay, so we end up with that. So here, this is cos theta plus sine theta equals 1. Okay, which we already said was 0, and theta equals pi over 2. Okay, those are the ones we already said we've got. Then we have multiplying up. So we'll have 1 equals 2 minus 4 sine squared theta. Okay, so multiplying up. Subtracting. dividing through by -4. And then from here we have sine of theta equals half, or sine of theta equals -1/2. All right, if sine of theta equals -1/2, or sine of theta equals half, you're going to get from these, you're going to end up with sine of theta equals half. Let's use our calculators. All right, that'll be 1/6 pi. Okay, pi equals, if it equals -1/2, you're going to end up with -1/6 pi. Okay, so we're going to need to cast from here just to double check whether anything falls in. So what I've got 1/6 pi be here, C A S T, so that won't be there, that'll be 5/6 pi. And then here, -1/6 pi, that falls out. The next one around, we passed pi, okay, so that one doesn't work, we don't use that. All right, so our solutions were theta equals 0, pi over 2, 1/6 pi, and 5/6 pi. Okay, a really, really tough question. That whole thing was very, very difficult. All right, next up, the diagram shows this function f of x, which is a bit of an awkward one. We need to find sketch the graph. The first thing is that the inverse would go mirror line across y equals x. Okay, just like that. All right, so this would be just somewhere below there. We've got any other mirrors that we can really use, any nice ones? That one's quite a nice one. Okay, so that's going to go here like that. Okay, it will also hit here. So I'm going to get something that looks a bit like that. There we go. Okay. Next, find an expression for the inverse. All right, fine. Well, we say that y equals let y equal 3 plus 2 sine of 1/4 x. Y subtract 3 all over 2 with an inverse sine in front of it equals 1/4 x. So that'll mean 4 plus of the inverse sine gives me my form. Okay, so that tells me that the form of this is right. We get inverse f of x would be 4 lots of sine to the -1 of x subtract 3 all over 2. Okay, not too bad. Next up it says g of x, which is actually the same as f of x. G of x, but it's just that f of x is only defined up to a certain point, whereas g of x isn't. It says complete the sketch. Okay, well, fine. All right, to complete the sketch, we just end up with the same kind of bit, just with like this mirrory bit here. Watch out for that. You've got the y-intercept there as 3. Okay, it's a little bit tricky, but there you go. So we end up with it just sort of goes like that. Okay, my sketch isn't absolutely exact. There's going to be some other bits and pieces you'll need to just keep that tidy. It's just a quick sketch. I don't want to spend ages over that. It's only worth 2 marks. Anyway, describe fully a sequence of. Oh, does it have an inverse? Yes, it does, because it's 1-to-1. Actually, I shouldn't have included that bit there, should I? Okay, it doesn't turn back on itself here. This is a 1-to-1 function. So yes. You could also say that it is strictly increasing. It's also a nice way of doing it. Okay, it doesn't go kind of there past that. All right, it just kind of goes there and doesn't start to turn back on itself. All right, describe fully a sequence of transformations. So first off, you work inside the bracket. So there is first. First, we deal with that. Okay, remember if it's inside the bracket, it's affecting the x's, but it sort of tells a lie. So there will be a horizontal stretch factor 4. Okay, so it's stretching it out like that. Then we use the 2 vertical stretch factor 2 like that. Okay, and then translation in the vector 0, 3. Okay, there's that 3 there. Okay, which makes us move up. Remember, it just goes from the inside, the most inside to the outside, okay, and you should be okay. All right, next. The second term of the geometric progression is 16 and the sum to infinity is 100. Okay, so the second term, that'll be AR, so AR equals 16, and the sum to infinity, which is A over 1 minus R, A over 1 minus R must equal 100. Okay, cool. All right, so that means that R equals 16 over A. Fine. Okay, which means that A over 1 subtract 16 over A must equal 100. All right, fine. A equals 100 multiplied by 1 subtract 16 over A. Okay, that seems again absolutely fine, nothing too scary going on there. Next I'm going to call this A over A, so I'm going to end up with A equals 100 lots of A subtract 16 over A. Multiplying up that A, I'll end up with A squared equals 100 A minus 1600. So this is multiplying up that A and expanding in that 100. So that'll end up with A squared minus 100 A plus 1600 equals 0. I'm going to just solve this by you can use quadratic formula, whatever you want. I'm going to use completing the square because I find it quicker than using a calculator. Square, take away 2500 plus 1600, 0. There's 900, so you end up with A equals, well, that 900 will go over, it will get rooted. Square root of 900 is 30, so that'll be plus or minus 30 with a 50. A equals 80, A equals 20. Okay, those are the two solutions. Show that the nth term of one of the two possible geometric progressions is equal to 4 raised to the n minus 2 of the other geometric progression. Now, I'm not sure which way around it's going to go, so what I'm going to expect is either that it's going to be 4 to the power of n minus 2 times one of them will directly prove it, or I'll use 4 to the power of n minus 2 times the other one, and it will just get it upside down, basically. It will just be the wrong way around. So what I'm going to start with is I'm going to start with A, lots of. But I'm going to use the 80 first, so I'll have A plus A, first number, which is A here, multiplied by R. In this case, if A is 80, R would be 16 over 80, which is 0.2. Raised to the power of n minus 1, that would be the nth term rule. Okay, and I'm saying that this A here could be 4 to the n minus 2. And that should equal, if I plug in 20 into the nth term formula, A times by, well, if A is 20, 16 over 20 would be 0.8. Raised to the n minus 1. Okay, so let's just double check some bits and pieces here. So we have this is fine. So what I'm going to start with is I'm going to say, well, what about if I said that, yeah, this is for the n minus 2, fine, but I'm going to call this 4 times 20 times 0.2 raised to the n minus 1 equals 20 times by 4 lots of 0.2 the n minus 1. Okay, so there's a little bit of messing around going on there. All right, now I can see that the 20s are going to cancel, so I'm going to end up with 4 to the n minus 2 times by 4 times by 0.2 to the n minus 1 equals 4 to the n minus 1 lots of 0.2 to the n minus 1. So this is the bracket law there. Well, now the 0.2 to the n minus 1s are going to cancel. This will be 4 to the n minus 2 times by 4 to the 1. Does that equal 4 to the n minus 1? Yes, it does. So therefore, left-hand side equals right-hand side. And so, yes, it does work. If you multiply this side by 4 to the n minus 2, you do get that side. Alternatively, if you tried this side here, it wouldn't have quite worked out. You would have had to have done like 1 over 4 to the n minus 2. It just comes down to luck which one you get, and it's not that much work. So just try either side. All right, next. The equation of a circle. So the equation of a circle is fine. This circle has the centre A3. All right, to show that one possible value of A is 4 and find the other possible values. All right, cool. This is tangent to the circle, so that if I plug this in, then the discriminant should equal 0. All right, so we're going to end up with x squared minus 2xa plus a squared plus, well, this is going to be a half of x plus 6 minus 3, so that will be plus 3 all squared equals 20. It will be x squared minus 2ax plus a squared plus 1/4 x squared plus 3 over 2 plus 3 over 2 plus 3x plus 9 equals 20. Let's collect it together. 5/4 x squared plus 3x minus 2ax plus a squared minus 11. Alright, now in this case b squared is going to be 3 minus 2a, it's all the coefficients of x squared, minus 4, lots of a, it's cool, the 4 and the 4's will cancel out, lots of c, which is a squared, minus 11, must equal 0 because we've got a tangent. Alright, cool, so this will be 9, subtract 12a plus 4a squared, subtract 5 lots of a squared minus 11, 5 lots of a squared minus 11 equals 0. 9 subtract 12a plus 4a squared minus 5a squared plus 55 equals 0. Okay, so this can come out as negative a squared minus 12a plus 64 equals 0. Let's tidy it up a little bit. A squared plus 12a minus 64 equals 0. A plus 16, a minus 4 equals 0. So therefore a equals negative 16 or a equals 4. The other solution is a equals negative 16. Okay, cool. And we verified what we needed to. For a equals 4, find the equation of the normal to the circle at P. Okay, so when a equals 4, we've got the normal to the circle at P. Cool. So let's deal with. I want to find a good sort of starting point. Okay, and a equals 4 at the point P. So first off, I want to find out where does this line meet? Where do these two lines meet? Well, the last time that they were plugged it together with A's together is here. Okay, I don't want to do the bits where I've got like I don't want to do the parts where I've started trying to do the discriminant. This is both equations next to each other with an equal 0, so I'm going to substitute 4 into that. So I'm going to end up with 5/4 of x squared plus 3x subtract 8x, so that's going to be subtract 5x. 16 take away 11 is plus 5 equals 0. Multiplying through by 4 and dividing through by 5, I'm going to go with cancelling out the 5's, multiplying through by 4, I end up with x squared minus 4x plus 4 equals 0. Okay, so the equation of the normal will happen when we've got x minus 2 all squared, 0. So that means that the point is equal to 2 something, okay? So this means that tangent meets the circle at the point 2 something. Now that satisfies here. So half of 2 is 1 plus 6 is 7, okay? So the tangent line and the circle meet at the point 2, 7. The normal will be a perpendicular gradient to this, so the m of the normal will be negative 2, passing through that point there. Okay, so this will be y minus 7 equals negative 2 lots of x subtract 2. This will be y subtract 7 equals negative 2x plus 4. Y equals negative 2x plus 11. Okay. Next up, for a equals 4, find the equation for the two tangents of the circle which are parallel to the normal found in B. Alright, so this is a little bit of a confusing one. So the first thing that I'm going to do is I'm going to kind of imagine where the circle might be. I'm going to go with my Centre of my circle, if A is 4, my centre of my circle will be 4, 3. Okay, I'm going to get an idea of that. I'm going to get an idea of where the point P was. The point P was 2, 7, so somewhere up here. Okay, and that gradient there, as we expected, was negative 2. Okay, so there's 2, 7. And what we're saying is that that must be a point on the edge of the circle. So the circle will go somewhere around like that. And we're saying that there's another tangent that hits like that. And there's another tangent that hits like that. Okay, there it is. Now, one thing that's quite lucky about this is that this will be a square and this will be a square. Okay, so we can use that to find out what this point here is. Okay, so this goes across 2, down 4, so this will go across 4, up 2, and so this will be 8, 5. Okay, and knowing that this is 8, 4, 0, 5, 3, 1. Okay, now each of those will have the gradient negative 2, so this will be y minus 5 equals negative 2 lots of x minus 8. Y minus 5 equals negative 2x plus 16. Y equals negative 2x plus 21 is one of the equations. And y minus 1 equals m, which is negative 2 lots of x minus 0. Okay, so that will be y equals negative 2x plus 1. Okay, so those are my two equations for my tangents, which are parallel to the normal found in B. Alright, that'll do for now.